Alrighty. In this video, we're going to be talking about lesson 4.3, combining functions. All right. In this topic, is this we're going to be talking about basically how to combine two different functions to make a new function. We start off with the sum, which is basically if I take two functions, f plus g of x, this is the same thing as just adding whatever the f of x function is and the g of x function. One thing not to hold up on, it doesn't have to say f of x and g of x. This is just stating if you have two named functions being added together, you can simply just add the two functions up. You also have the difference, which is the same concept, but with the minus. So again, notice that the first named function is what is first, and the second named function is what's being subtracted from. And then you also have the product, which will be fg of x, which is then f of x, g of x. Some books will actually put the solid dot to indicate multiplication. I do not, because when we talk about composite functions, you might sometimes get confused with, oh, that's a dot. I'm doing composites rather than just multiply. So if it's written like this is a product. You also have quotient, which if you have it written like a fraction, remember that it's just division. And then the big one, which is the last part that we'll talk about, is a composite. Right? And it's kind of written like this, where you'll see F, O, or like an open circle. It's not even an O. So this is not like fog. So let me try to do a better job here. So it seems like a closed dot. Let me just write it bigger. Right? So that's not an O. That's like F of G of X, which can also be written like this as well. So again, this is written as the F function of the G of X function, which basically just means you're taking a function and you're replacing the x of another function to create a new function rather than just doing one of these operations. You're basically substituting the x with a different function. So this can be a more challenging topic, but hopefully after a few examples, you don't find it to be too challenging. All right, so let's do some examples. Best way to learn math. And we'll look at number 1. So in all of these examples is asking us to find f plus g of -1, f minus g of -1, f times g of -1, and f divided by g of -1. All right, in the very first example, it's saying, all right, f of -1 equals -3, and g of -1 is equal to 5. So when we're working these steps out, this is f plus g of -1. Well, if you go back to how I wrote that, f plus g of x is written as f of x plus g of x. Instead of an x, just replace it with that -1. So this now becomes, so I'll write it all together. So f plus g of -1 is equal to f of -1 plus g of -1. Well, then you're told what f of -1 and g of -1 is. So this really just becomes -3 plus 5, which in this case is 2. All right, so be able to do questions like that. And we'll do some more with the rest of the operations. So if we take f minus g of -1, just like in the addition, I can write it as f of -1 minus g of negative 1. I do not distribute this negative. This is not how this works. This is a function of g where x is a negative 1, and then we're told what the y value is. So in this case, this is negative 3 minus 5, which will give me negative 8. Part C says times, so this would be f times g of negative 1. And again, from the notes we just took, that's the same thing as f negative 1 times g of negative 1. So f negative 1 was negative 3 times g of negative 1, which is 5. You can use parentheses or this solid dot to indicate multiplication. So you should get negative 15. Do division as well. So f divided by g of negative 1, which would be f of negative 1 over g of negative 1. So f negative 1 is negative 3. G of negative 1 is 5. Can't simplify that, so you just keep it as negative 3/5. And that's it. Now, obviously, it does get a little harder than this. So let's look at one like that. So let's look at number 3. Same questions. I'm looking for A, B, C, and D of f, g, and negative 1. So I'm not going to rewrite it. But we're now given that f of x is equal to x squared minus 3, and g of x is equal to just x. So here's my recommendation. Before you do any of the adding, subtracting, multiplying, dividing, since you know you're finding it for negative 1, go ahead and figure out what is these functions at negative 1. So this right here would be negative 1 squared minus 3, which give me 1 minus 3, which will give me negative 2. So f of negative 1 would just be negative 2. So, and then here would just be straight negative 1. So here, what we just did in question 1, they started us here, so we're able to do the math of the combining functions. Here we're given functions. We have to do some math to get to that point, and then we can jump right into it. So now I'm ready to jump into it. So the first one was f plus g of negative 1, which we've already determined in question number 1 was f of negative 1 plus g of negative 1. So in this case, that would be negative 2 plus negative 1, which gives us negative 3. And now we're able to do the same type of process that we did on number 1. So it becomes a lot easier if you go ahead and define it now rather than doing all the work, then plugging in, then getting the answer. You could do it that way. Just to me, it just doesn't seem very organized. All right, so then that would give me negative 2 minus a negative 1. Again, there's already a minus and your answer is a negative. So don't forget to write an additional negative. So that makes it a plus, which will give you negative 1. And then I believe the next one was multiplication. So in this case, that's going to be negative 2 times negative 1, which gives us a positive 2. Next one is division. Again, we wrote all this in the previous question. So then that becomes negative 2 divided by negative 1. Now, in the previous question, I just left it as, I think it was negative 3/5 or something like that. In this one, I can't just leave it because it can actually be simplified. Negative 2 divided by negative 1 is, in fact, 2. So 2 would be the answer here as well. All right, another type of these questions is it can be given to you as a graph. All right, so once again, I didn't snip it, even though I wish I could snip it on this whiteboard here instead of having to do a Word. Makes editing these notes a lot easier. There we go. So here is our graph. We will try our best. So there looks to be, do a different color. Determine them. We'll do what the book has, blue and purple. That's good. So blue, it goes up to 4. So 1, 2, 3, 4. And then looks like goes through. See how accurate we have to be. but we do have to be pretty accurate. So at -1, okay, there's a point here. There's a point here. So there's a point there. There's going to be a point here. And then we're about here. Alrighty. I hope that's all we'll need. If I have to go back and define it, I can. All right, let's graph the next one. Oh, there's purple there. All right, so we have basically a point here, and then it looks like it's just going up 1 over 1. So we'll make a couple defining moments here. If we have to go with further detail, I think that would be a lot easier to follow. All right, so when you're given a better graph on your homework and of course your textbook, but you're given a graph and you're still asked to find all of those functions. So in A, that was still going to be f plus g of -1, which again is written as f of -1 plus g of -1. So what happens now is if I label this is my g function, and this is my f function. So all you have to do is basically figure out what the y value is for those respective functions. So f of -1. So here's -1. F function's the purple. The answer was 2. That's what if you look in your book. Oh, my bad. Yeah, F. Yeah, it lands on 2. Right? And we landed here on 2 as well. But if you need a clear picture, definitely use that as a reference. But so you go to -1, you landed on 2. So that's the result you put on. So you go to the x value, see what is the corresponding y value. Do the same thing with g. G, I went to -1, and then I go up and it lands on 3. So this is going to be +3. So the answer here is 5. So you just got to be able to pull the y value out of the corresponding x value for the corresponding function that you're looking at. And then you write those results and then do the math. So let's do a subtraction. All right, so then I go to f -1. Again, we know that that's going to be 2 minus, we know g of -1 is 3. So this becomes 2 minus 3, which is -1. So once you do it once, a lot of times you can just pull information from it. It's not so bad. This one then is just f g -1, which becomes f -1 times g -1. So again, we've done the work. So this is going to be 2 times 3, which gives me 6. Same process, but with division. In this case, that would just be 2 over 3. Can't simplify, so you leave it like that. All right. So again, it's pretty straightforward as like number 1. The only issue is you need to just look at the graph and then pull the corresponding values out. All right. So hopefully that was a pretty straightforward understanding there of doing the adding, subtracting, multiplying, divide. I try to give you multiple scenarios there. But let's look at composite functions next. So here we go. Ooh. So we'll look at number 23. And you're asked again to use the information to find what we call f of g of 3. And on number 23, you're told that f of -5 equals 2 and g of 3 equals -5. All right, so the way this works, you write, this is how it's written or given to you. And then according to the very first page of notes, this is written the same way as f of g of 3. All right, so what happens is you have to, the way I teach it, or it's probably how everyone teaches it, with a composite function, you want to work inside out. So I want to do the inside of the function first, then work on the outside of the function. What that means is identify what is g of 3. What's the inside function as a number itself? Well, it tells us g of 3 is equal to -5. So therefore, this is really asking, what is f of -5? Well, f of -5 is defined to us as the value of 2. And that's it. So I did the inside first, got a value, then I did the evaluated the outside, and which gave me that answer. Right. Obviously, that's a real easy one once you understand the concept. So let's do one with more algebra, I guess you could call it. So number 25, so this will be f of x equals x squared minus 3, and g of x equals the square root of x. All right, and again, we are asked to find f of g of 3, which again can be written as f of g of 3. All right, so what we're going to do first for this problem is figure out what g of 3 is. So let me do that in a different color. So I'm going to find out what g of 3 is. So when I do that, I replace this x with a 3. I'm going to replace that x with a 3. So that just comes square root of 3. Can't go any further than that. So therefore, this is really asking, what is f of square root of 3? So realize that I just replaced g of 3 with what it actually equals. So now I'm going to do the same thing. I'm going to take this and I'm going to replace it with the x of the corresponding function for f. So this now becomes the square root of 3 squared minus 3. A square root and a square will cancel, and I'm now left with 3 minus 3, which in this case is equal to 0. All right. And that's what you would do with some algebra. And of course, they also have some graphs. Do my best to draw some graphs for you. So let's look at number 31. All right, there's our graph. We'll go back to our blue and purple. So it looks like at -5. So 1, 2, 3, 4, 5. Again, you can always reference this in your books. Looks like there's one at 2, -1, and then one at -2, -1. All right, so hopefully that's pretty good. If not, we might have to go find some other values. And then we had a what looks to be like a square root function that starts here, goes here, and looks like 1, 2, 3, 4 up 1. Something like this. We have to go find more. We can. All right, so we're going to do the same thing. We're still asked to find f of g of 3. And I know, again, I probably said this already, but I'm not spelling out FOG. It is f of g of x or 3 or whatever the value is. Right? So again, this can be rewritten as f g of 3. So just like beforehand, I need to define what g of 3 is. So I'm going to go to, oh, I need to label this. This is my f, and this one is the g. So g of 3 is the blue one. So I'm going to go to 1, 2, 3, and of course, 1, 2, 3, 1, 2, oof. Oh, looks like 4. Okay, so we got 1, 2, 3, 1, 2, 3. It looks like 4. So let me put another point there because obviously we needed it. My line's a little bit off now, but it's basically at 3 there. If we have a better graph, the coordinate was 3 comma 4. So that means that g of 3 is really f of 4. So then I can go to 4 and I see that that value is 1. So again, you'll have nice clean graphs. I won't ever graph something like that and then put it on a test. It'll be graphed for you by a nice computer program. All right. So let's look at number 32. Another graph. Really testing my skills today. They're not very good skills to test when it comes to drawing. All right, so our first one looks like a linear line. Let's get some good points involved. And none of them look like good points. Oof. Looks like 4, 1 might be a good one. Like 3, -1, maybe. Five, 3, maybe. It's gotta be what it is. One, two, three, four. 1, 2, 3, 4, 5. 1, 2, 3. This is 1, 2, 3, 1. Don't have good spacing. Pretend that's it. Um, so we'll try our best there. Definitely gonna be using the book to help us with this one. Um, and then the graph, this one looks a little bit, no, doesn't look any much better. All right, so we get something like this. All right, so we'll do our best with that. So this was my F, this was my G. And again, you're still asked to find F of G of 3. So again, that's F of G of 3. So I figure out what G of 3 is first. So here's my G. That's 1, 2, 3. I estimated it to be about -1. And then I'd go to F of -1, which I would estimate is 2. Okay, were we? Yeah, so that's about right. All right, and so again, just analyzing a graph. So hopefully you understand that part. Now that's again the easy parts because we always get a number out of it. Most of our composite functions or just our written functions itself aren't always just numbers. Sometimes they're just a new function. So if we look at number 34, you're asked to find f of g and the domain and find g of f and the domain. So let's look at that. So f of x is equal to 1 over x, and then g of x is equal to x minus 1. All right, for starters, um, define the domain of these functions. So the domain of f is, again, all real numbers, except for what makes it 0 on the denominator. So in this case, it's 0 itself. It could be anything but 0. The range, because you can't plug in 0 to get a number, happens to also be -infinity to 0. Again, if you also need a reference, this is what the parent function looks like. So you can see I don't cross the x or y axis. G of x is a linear function, so the domain and the range of both is all real numbers. Now, depending on which one we find, so let's look at f of g of x. All right, when we plug this in, and you're talking about the domain, well, let's find the function first and then talk about domain. So if I take my g of x, which is x minus 1, I'm going to plug it into every x of the f of x function. So in this case, this becomes f of x minus 1. So then I take the x minus 1 and I plug it in. So that gives me 1 over x minus 1. Simplify if you can. If you can't, then there you go. Now, when we're looking at this function, you can't, there's no limitation. So if I plug in a linear function, there's no limits on the domain and range. The only limits is the current one. But therefore, the one that you're plugging in, if there's no limits on what you're plugging in, then you can just look at what you have currently. So in this situation, the value that would make this 0 would be the value of what? So the domain is just going to be negative infinity to 1 union 1 to infinity. Now, if you recall, this would just shift it to the right 1. So the horizontal asymptote would be the same. So the range would not be affected by this 1 and would still have the same range on the original function. So this would be negative infinity to 0 union 0 to infinity. Because remember, graphically, I'm just going to shift right 1, but the graphs are still like this. Or now it's 1 I can't touch, but I'm still not touching that y-axis. Right? And then we got to look at g of f of x. So in this case, this is now going to be g of my f of x, which is 1 over x. And when I do that, I get 1 over x minus 1. Now, this has a limitation. The domain can't be 0. So when I come over here to this function, I can't use 0. In this case, I still can't use 0. So it's okay there. So basically what happens is the domain ends up remaining as the negative infinity to 0 union zeros. Sometimes it plays out that it could be 0 because things will cancel, but it still couldn't be. We'll hopefully see an example like that. And then the range will still be the same. Oh, actually, in this case, you're shifting up 1 or down 1. So this would be negative infinity to negative 1 union negative 1 to infinity. Now I'm looking over here at the directions too, and I realized I didn't even have to find the range. I just need to pay attention to the domain. So I'll do the range now, but the rest of the questions will just be the domain. That's all I think it really focuses on the homework as well. All right, so that's a pretty simple one of us understanding of just plugging in functions into functions and talking about their domains. Let's look at more complicated ones and talking about their domains. So let's look at number 36. This would be f of x equals 1 minus x, and g of x equals the square root of x. So again, if I look for f of g of x, this will be the same thing as f of g of x. So I'm going to plug in square root of x into my x. So that would give me f of square root of x, which will now give me 1 minus the square root of x. So here, the domain, the square root function, remember this. So I am limited from, not negative infinity. I'm limited from 0 to infinity, but I can include 0. The range here, again, still linear, so the domain here is not limited. But so here, when I'm plugging a limited domain in, this is what I'm allowed to have. In this case, it's still the only restriction I have, but had that gone away, I would still be limited to just this. So my domain here would be the 0 to infinity as well. All right, if we look at g of f of x, that would be 1 minus x. In this case, I'm replacing this whole function with this x right here. So that becomes the square root of 1 minus x. Now, in this case, when I plugged in a linear function, there was no limits. So I just got to pay attention to what are my limits here. And when you're talking about a square root function, basically this can't be a negative. So if you can't automatically see what x can't be, then what you can do is you can take the inside function and set it greater than or equal to 0, because that's what it has to be. It has to be greater than or equal to 0. It can't be a negative. So I will subtract an 1, so that gives me negative x greater than or equal to negative 1. And then I'm going to divide by negative 1. And if you remember from the review videos, anytime I divide by a negative, I have to flip the inequality sign, and that gives me a positive 1. So that means that x has to be less than or equal to 1 in order to not have a negative result. So the way we'll write that domain will be negative infinity up to 1, but included. So that would be the domain of the new function. All right. So there's another example. Let's look at one more, and then we'll move on to a different type of questions you'll see. Let's look at number 39. So this is f of x equals the square root of x minus 1, and g of x equals x plus 1 over 2. So again, I'm looking for f of g of x. So this is f of g of x. I'm going to take this and I'm going to plug it in for my x. So this becomes the square root of x plus 1 over 2 minus 1. I don't think you have to go any further than that on the homework. Oh, they do. They want you to combine that as 1. So let's go ahead and practice that. So to subtract fractions, they have to have the same denominator. So I'm going to multiply this by 2. So this will then give me x plus 1 over 2 minus 2 over 2. I can then do the math on top, and then the denominator itself will remain 2. So if I do the math on top, this is x plus 1 minus 2. Well, plus 1 and minus 2 gives me a minus 1. So this is what they're going to be looking for on the test, so do watch out for that, or the homework as well. All right. Okay, so now that we have this, let's talk about limitations. So g of x is technically a linear function. The x is not on the denominator here. So the domain here does not have any limitations. So I don't have to think about that. I can just look at the end result. And again, if you're struggling with it, take it, set it greater than or equal to 0. So if I multiply both sides by 2, I get x minus 1 is greater than or equal to 0. And then add 1, I get x is greater than or equal to 1. So that means my domain of this guy is going to be 1 to infinity. Right? No limits plugging that function in. All right, it gets a little different over here. The limits here, hopefully, again, if you can't, I'll just do the math. I'm going to add 1. So I get x has to be greater than or equal to 1. So that's my limits there. So it has to be 1 to infinity when I plug it in. What I mean by that, let's look at g of f of x. That's just going to be g of f of x. And again, this time, I'm going to take this function and I'm going to plug it into this x. So this just becomes the square root of x minus 1 plus 1 over 2. Now, if you look at just the limits here, this is the domain. But you also have to consider this as just the domain. So right now, there is no restriction here. Again, what's going to happen, and maybe not so much now, but later down the road, if I was to plug in a square and this went away, you would see that there wasn't a limitation, but then there would have been a limitation because of what you started with. So in this case, nothing will change when it comes to the domain of g of f of x. All right, so I don't want to go get too hard when it's not going to get too hard, you know. All right, so the next step is to write each of the following functions as a composite of 2 functions. So what they're doing here on number 45 is they say, hey, f of x is equal to 2 over 5x minus 1, right? And they're basically asking if I want to write this as f of g of x, which again is written like this. What would g of x have to be And what would f of x have to be? Well, maybe I should use a different letter than f. We'll do h. So what would g have to be and what would h have to be in order to get this function of f of x? All right, so best way to do this is figure out what is the h of x? Like what am I plugging into so I can figure out what I can take out? Now, when I look at this, the only thing I can really do with that x, so let's analyze, is I can let that be a regular x. So what I'm thinking here is if I let this be a regular x, then I'm plugging in a 5, and then I can let it just be 2 over x minus 1. So think about it that I say 5, it should be 5x. So if I let g of x be 5x and I let h of x be this, if I replace x with a 5x, I get to this point. So you want to look at what you can replace, which has to involve the x. You could even go probably one step further with that, and you could have probably said, I even put an or here. You could have said 5x minus 1, pending that this is just 2 over x, because I can replace this entire x with 5x minus 1. I'm curious how the homework is assigned, if it'll take multiple answers. I don't know if it will or not, but this is the one that they had in the books. So if this doesn't work, even though it is correct, try this route as well with the type of function. Again, the best thing is kind of just unsolving a puzzle. What could I replace to put in there? And that replaceable thing is what my g of x is, and what could have been replaced is what the h of x is what's left with. All right, so let's do another one. See if we can do maybe a challenging one or maybe see a pattern to help you out. So x cubed minus 5x plus 7. So again, here's where my x is involved. Here's another function involved. I'm definitely going this route of I'm replacing this guy. So my h of x, well, if I write it as h of g of x, I say that's equal to my f of x. My h of x would just be the absolute value of x plus 7, because I'm going to replace that with this guy. So therefore, my g of x would then just be that guy. That's the easiest thing I see. And again, making sure to see where they go with. That's what they went with as well. So trying to replace, I guess, as much as you can. Maybe that's the route we should go with. Replace as much as you can and be left with a more simpler problem of the original. All right. So kind of play with that on the homework. You got questions, feel free to reach out and let me know. In each, the next set, it says each of the following exercise use the information given to find g of x. So you'll be given questions like this. Let's look at number 55. You're asked to find what is g of x. Given that f of x is equal to x squared minus 3 and f minus g of x is equal to x cubed plus x squared plus 4. All right, so this isn't as bad as you think. All right, so we know f minus g of x is equal to this. So that's what I'm going to write. I'm going to say, all right, so f minus g of x is equal to f of x minus g of x. Right? I know f of x. It is x squared minus 3. I don't know g of x. But I do know these together give me x cubed plus x squared plus 4. So once you have this kind of layout written out, your goal is just to solve for g of x. So to do that, I'm going to subtract x squared, lining up my values, and then I'll add 3, lining up my like terms. So that will go away. I still have a negative g of x, but then that will go away. And I have x cubed plus 7. But that's what negative is. If I multiply everything by a -1, I get g of x is equal to negative x cubed minus 7. And then that's it. So now you have g of x. If you don't trust it, you could take the g of x, subtract it to the f of x, and then you should get to this outcome, in which you will. All right, so let's do another one to make sure you understand that. So let's look at number 56. All right, this one is f of x equals x squared. And then g of f of x is equal to the square root of negative x squared plus 5 plus 4, but on the outside. There we go. All right. So we're looking for g of x. This is kind of like what we just did in 45 and 48. They give us the total answer. They give us one of them. So they're like, all right, f of x is what you're plugging in to get the x squared. So basically, if I'm plugging in to get the x squared, anywhere there is an x squared, I think what I'm going to do is I'm just going to replace it with a negative, and we'll see if that works. So negative x plus 5 plus 4. So if this is g of f of x, then this would then be g of x squared. So I'd replace x with the x squared, and bam, there it is right there. Had that not worked, I would have tried to maybe pull some more information out or anything like that. You could have probably solved this as well. Oh, man, that'd probably be a little bit harder because you're trying to, yeah. Yeah, I would probably solve it like we did 45 and 48. Figure out what's the original function that you're plugging into. And that'd probably be the best way to approach it. All right, one more problem. Just like most homeworks and math classes, there's always a application problem or a word problem. So let's look at number 60. This one says a widget factory produces n widgets in t hours of a single day. The number of widgets the factory produces is given by the formula. So we are given n of t equals 10,000 t minus 25 t squared. And it's limiting us to 0 to 9. The cost C in dollars of producing n widgets is given by the formula. They're given to us as C of n equals 2,040 plus 1.74 n. And it's asking us to find the cost C as a function of time. So we're looking for C of t. All right, best approach with this is, since I'm looking for C of t, what we're going to do is we're going to take our t function and plug it in so that we have nothing but t's. So when you're looking for a function where the t is and you want nothing but t's, you're going to take that function that has the t's and replace the other function. So if I want to have a function of cost in time, I want that t. So what I'm going to do is I'm just going to replace the n with that function. So that would give me 10,000 t minus 25 t squared. So all I got to do is really distribute. So this gives me 2040. 1.74 times 10,000, that's 4 zeros. So that's going to be 17400. So 17,400. Oh, it's a plus. And then the T. Oh, man. No shame in a calculator. So that's going to be 25 times 1.74. And that gives us 43.5 T squared. Right? And that's it. And then you have a function of cost in time. So even though it's a word problem, I find word problems to be way easier than the other problems. It's just reading and understanding the simple tasks that you have to do. If you have any other questions, again, feel free to reach out. Again, I hope these videos are really helping you out. Until the next one, bye.